We are now going to learn about what exploitable CVE really means. So please give it up and welcome Hector Eryx Paredes. Thank you.
Hello, everybody. Hope you have been enjoying an amazing conference days in besides Budapest. Unfortunately, I couldn't travel to Budapest to present this live, but nevertheless, I wanted to share with you a few of the things that we have been doing in the company that I work here at Lyft. Understanding better where attacks are faced, understanding better what actually like the vulnerabilities, what is the actual risk that they have, what is the actual impact that they have, and what actually exploitable really means for the vulnerabilities that we are managing. So my name is Hector Eryx. Most people know me as Eryx. You can find me as HERYXPC in most places. I work at Lyft, which is a ride-hailing company, but we also have bike share and like black cars and other services worldwide. Now we are a worldwide company as we have some presence in Europe and the Middle East. I study computer science in Mexico and England. And well, just to say also that anything that I say here is just me saying stupid things, and it does not represent any organization or company or whatever that I am part of. And this is just a lovely meme that a few friends did to me some years ago, saying that I am hacker because they are the only cybersecurity person that they knew. What we'll be talking about? Well, we'll be talking briefly about the economy of vulnerability research, the economy of exploit development. We'll be talking about like what having an exploited vulnerability really means for a red team, and then what an exploited vulnerability means for the blue team. And my view here is going beyond and deeper on what's on the surface of like known vulnerabilities, and really trying to get you like kind of like a hands-on experience on, hey, I mean, this is what really means when somebody says that you have a vulnerability and that can actually be exploited. So who finds vulnerabilities? Who is doing the vulnerability research? People like you. I mean, there are a lot of security researchers worldwide doing an amazing job on finding new vulnerabilities, on investigating systems, either like old systems or new systems, trying to identify software issues, bugs, that can reflect or can impact security concerns. Mostly we try to identify things that impact the CIA triad: confidentiality, integrity, and availability. And this is done both in the academia and in the industry. So people at universities are doing security research. People working in companies that are focused on vulnerability research are doing that. People are working in companies that are doing security products are doing that. And there are, of course, security researchers that like wearing hats of a certain dark color that also are doing vulnerability research for their own purposes that might not look so ethical. But people are finding a lot of issues in systems that can be reflected as a vulnerability, which if we want to define vulnerability, it's a security issue, a software issue, or a process issue, a bug that affects one of the security constraints defined in the boundaries of the system. And interesting enough, contributors, maintainers, people that it's actually building things are also vulnerability researchers. I don't know if you have heard about the case of XC Utils, which was a malware that was injected into a library that it's part of like the dependencies of OpenSSH, which meant that if that malicious package that malicious library will be included into OpenSSH, a lot of servers using SSH will have a remote access to a RAT installed without even notice. And who found this kind of like issue was a Postgres developer at Microsoft. He was not focused on security, but he found something weird on the CPU and memory while doing some tests and found this kind of like problem. And then why do people do vulnerability research? Well, fame and fortune mostly. I mean, everybody wants to get rich, everybody wants to like be well known. And if you find a vulnerability that has a vulnerability ID, a CVE ID, then you will get a certain fame and you will get attention on what you are doing as a security research. People also would like to just break things for fun because it's fun breaking things, being honest with you. And sometimes it's people trying to understand more and then figure out something that doesn't look right. And now all these security concerns that are flagged as a bug, then how can they be useful for? Well, mostly they are useful for exploitation. So once there is a known vulnerability, or once somebody on a 0 day identifies a vulnerability, identifies a vulnerability that is not shared among like everybody, the next step is exploiting that. The next step is trying to break into the security constraints via this security issue. And who tries to exploit these things? Well, state actors, mostly military and intelligence agencies, security researchers that doesn't want to just like remain into, hey, I found a security problem, but I want to go to know how far this problem actually is, and being able to exploit that in a chain of like problems or a chain of actions, processes, commands that actually allow you to exploit. And what mostly people want to get is like command execution, especially if it's remote command execution. But there are other constraints that you might want to like break, like authorization or authentication within the elements of the system where the vulnerability is found. So yeah, I mean, security researchers want to exploit and know more on what's the actual problem there and how bad can it be, right? There are also companies that buy these exploits. I mean, if you develop an exploit for a known vulnerability on iOS, probably one of the big names on spyware solutions will try to reach you and buy the exploit that you generated in order to include that into their suite. And of course, well, cyber criminals are trying to exploit vulnerabilities in order to get access to systems or bypass security constraints. And sometimes even some lucky script kiddies can actually be around enough with vulnerability or with, and find out how to exploit it. And now let's add the AI magic. I know that a lot of the time people are talking now about AI, but it's real that this is shifting and changing the cybersecurity industry worldwide. We are seeing more and more disclosed vulnerabilities. A lot of that is just rubbish. I mean, it's just AI slop. It's vulnerabilities that are not a real security issue, are just bugs, or probably not even that. But this is growing and growing, and the AI it's getting better and better and identifying these vulnerabilities, these problems. And as the frontier models are evolving, and as more people is using AI to orchestrate and build agents that can find security issues, reading the code, doing fuzzing, doing dynamic testing, and more vulnerabilities are being exposed. So we are seeing a very high increase on the number of vulnerabilities. And then also exploitability, it's decreasing, right? I mean, people is testing now how to use AI agents to generate a chain of exploits of vulnerabilities and generating malware and things like that. And despite that, there have been efforts to kind of like reduce the usage of AI to do vulnerability research and do especially like exploit development because of the ethical consequences of that. There are many, many ways to just overcome those guardrails and continue doing exploit development. And now this part of this AI magic, it's that, well, this is also a new attack vector. I mean, we have heard a lot about prompt injection, and we have heard a lot about like model poisoning, and well, these agentic solutions that have like over-permissive access and authorization to run tasks. So yeah, this is a new attack surface that also a lot of people is trying to attack and exploit. Now let's get into like the actual thing. The scoring systems, I mean, the systems that try to help you to determine if a vulnerability is exploitable or not. They do not work, being honest with you. And there is plenty of academic research around, for example, the Common Vulnerability Scoring System, the CVSS, that is now on version 4, that demonstrate or that prove with data that the scoring system itself is not useful to determine how much is the risk or how likely is vulnerability going to be exploited. It uses to determine exploitability for metrics. I mean, each metric adds a weight to the scoring system, and I will show you an example on the scoring system later. That first is attack vector, that it's basically if it can be a network attack or a local attack that tries to exploit the vulnerability. Attack complexity, how difficult it's to exploit it, which can be low and high. Privilege required if there are no privileges or there are low privileges that are required, and user interaction. I mean, this vulnerability can be exploited just without any action from the persona that is identified as the user for that system, then requires no user interaction. And there is also the impact metrics, which are confidentiality, integrity, and availability, basically the CIA triad. So if it's a vulnerability would only impact confidentiality, but not availability, then the availability is not considered as part of like the calculation. There is also, on the other hand, the exploiting prediction scoring system, the EPSS. And the EPSS, it's a machine learning model. It's AI, actually, that tries to determine how likely a vulnerability will be exploited after it's been discovered. So with ingesting a lot of information into this model, they figure out how to determine a percentage of how likely is it that a vulnerability can be exploited. So it tells you the likelihood, not the actual exploitability. Now, if that thing is actually going to be exploited. And then another example, it's something that probably you all know, as this is part of like most governments in the EU. They have something similar to the non-exploited vulnerabilities catalog, which is a catalog that has records of vulnerabilities that have some evidence of attempted exploit. So whenever there is some evidence by one of the partners that, in the case of the US, the non-exploited vulnerabilities catalog, there is a partner that shows evidence that a vulnerability is trying to be exploited, then it's added to the catalog. It means, so this kind of like gives you a higher signal of this has actually been exploited. That thing can actually be exploited in your environment. It's hard to say, but at least somebody tried to exploit the vulnerability somewhere, and maybe they were successful. So going back to the CVSS metrics, the ones that we all use and that do not work great, the reason they do not work great is because they are not constrained, or well, the security research was constrained to a certain environment and a certain context. So if you try to extrapolate or move that context to your context, might be different. If you do not input the mitigations that you have in place, then that definitely will reduce the actual scoring. And to reduce or manage better the actual scoring, the CVSS provides a set of metrics known as the temporal or threat metrics, depending on the version, and the environment metrics that help you to adjust the severity for exploitation. So if there are POCs or there are plenty of systems that have been known that exploit this vulnerability, if there are more details about the exploits that are publicly available, if the environment where the vulnerability is actually found. It's like, hey, CVE 123 is found in your laptop computer. But your laptop computer has an EDR and has ways to block process and things like that. That helps to manage and reduce the scoring. And just for a curious note, the entity in charge of setting the CVS scores, or well, CVS scores are set by usually the certified number authority, basically whoever sends the information of the record for the vulnerability database. And usually they do that based on either the security researcher that set those metrics. And as a security researcher, you want to pop up as much as you can those metrics so that the CVE has a high severity. And also the maintainers, which sometimes might try to reduce the metrics, the score, because they don't want to look bad as like their software is insecure. So those two set the score, so set the metrics to set the score. And then the National Vulnerability Database was supposed to do the analysis on the actual security concerns, the actual analysis for the vulnerability, but they stopped doing that because they are lack of resources. We mentioned that we have like a large amount of vulnerabilities that it's increasing year over year. So they ran out of bandwidth to do analysis for every known vulnerability that it's recorded. Let me show you a quick demo of if you actually input the temporal metrics and environment metrics, the score will likely change. This is a vulnerability on OpenSSL, but for specifically email encryption, specific for certain protocol of email. So the actual impact, it's like you said after free, if I remember correctly. Sorry, a buffer overflow. It's a buffer overflow, which can be really bad. I mean, with a buffer overflow, you can even get possibly remote code execution, most probably like availability causing a crash in this case in an OpenSSL running. But then if we check the actual like conditions that need to exist, if we check that the exploits are really just in a proof of concept, there is no like functional exploits from there that have been known by, for example, the non-exploited vulnerability catalog. There is an official fix, and this has been well reported. And if you get into your details of your environment, like how actually it's impacted in your system, in this case, this vulnerability is found on systems, on my case, that do not handle emails at all. So that largely reduces the score. So if we were using the environment and temporal metrics, we will get like better results. But that means a high effort on doing the analysis for every system, kind of like every asset where the vulnerability is found. Now talking about the EPSS, the exploit prediction scoring system, it's pretty good, but it doesn't tell you exploitability. It just tells you a likelihood of exploitability. So there might be evidence that this vulnerability was actually exploited, but it's again just a likelihood that because somewhere it was exploited, possibly might be exploited in your environment. And common like metric or common number, it's that if the exploiting scoring system is about 50%, this is more likely to be exploited, right? So because it's more likely to be exploited based on the settings of the model, might be good that you take some action and well, consider that could also be more likely to be exploited in your environment. But again, it's not like super perfect. For example, the Log4Shell vulnerability that was well known some years ago, when it was released, when the vulnerability record was released, there was a rough 36% of chance in this scoring system that this was going to be exploited, but then that changed to 95. So in the period of time between like, hey, I mean, this could be exploited, but it's a low probability between like, this is a super high chance that has super high probability that this will be exploited because everybody was exploiting it, then there is a gap. So the message here, what I want to say, it's we don't need metrics. I mean, we don't need a new scoring system. It would be great that we had like a super perfect scoring system that can analyze things like super nice. And there has been plenty of academic research to improve the existing scoring system, the CVSS for CVEs. But we need deeper analysis. We need to better understand our environment, better understand the mitigation that we have in place in order to determine if a vulnerability can be exploited or not. So can we just exploit all? Because being honest with you, the only like strong signal that you will find is that you exploit the vulnerability. I mean, if you exploit log4shell in your Java environment with a small exploit proof of concept, then you have like the super strong signal that the vulnerability is real and that needs to be patched. But doing that with all the vulnerabilities, it's a very expensive use of resources and time. And that's not how adversaries work. Adversaries usually use known vulnerabilities for initial access or for privilege escalation. That's what's research and identified. And there's also the exploit complexity. I mean, building an exploit is not so simple, it's not so easy. You also need like have a specific condition where the vulnerability was found and translate that into the conditions that you have in, and if those kind of like match or resemble enough, then build an exploit that tries to exploit the vulnerability. So what you need to do better is understand your environment first and start your business first, because we should be determining the risk of a vulnerability being exploited based on the actual business impact that that could have and based on the context where it is found. So for that, I will show you a couple of demos. So CloudFox is a tool done by Bishop Fox that gives you kind of like an analysis of your cloud assets. And I will show you as well something that I use. I'm not saying that you should use that, but it's what I use and it's very helpful for me, which is named cartography that allows us to get the asset inventory very well connected. And now it provides an MCP, an MCP server that allows you to communicate with LLM models. So for CloudFox, this is quite simple. It's just a small command line tool that you can run. And once you run it, it goes through the analysis of your assets. It meets the security audit permissions in your AWS account, in the case for AWS. The security audit rule, that contains certain policies that allow you to read a read-only kind of like view of your assets. And with that information, it maps and connects like all your resources like EC2 instances, load balancers, S3 buckets, and things like that, so that you can go deep and do the environment analysis. And then what I use, again, is cartography, which I will show you quickly, which is basically a project that allows you to save in a graph database just 1 second. So this allows you to have a graph database that connects the different assets, the different resources that you have in Neo4j and a graph database that then it's doing ingestion that connects kind of like the different assets. So in this case, I have an account of Lyft.com, basically the public domain for authentication for my company that points to Envoy, which is what we use to route the traffic internally, kind of like the server mesh, which goes to a backend that backend has a certain source code that I can analyze for known vulnerabilities, for example, in the dependencies that the source code use. that has a container repository for images that has a certain image that is running in production. So if I scan that specific image in production, I can get information about the vulnerabilities that are actually running in production and that are exposed at account.lyft.com. And even have a team that owns that service, that application for accountability. And well, searching through this, it's kind of like cryptic because Neo4j uses Cypher, a very weird query language. But now with, again, the MCPs and the AI magic, you can do this drastically faster. I will go to the presentation. So again, Neo4j can give you like, cartography can give you a full picture of all your assets, how they are connected. And then with that information, you can do an analysis. Again, I am doing this analysis with AI now. I used to do this like completely manually. And I had to, when I do know how to kind of map my resources and my infrastructure on my head, but this is a massive infrastructure. So having an AI that can help me to summarize and build, for example, dashboards and help me on doing the analysis on what is like most critical, what has the biggest impact, it's very, very useful. So this is the dashboard. I generated that with a prompt, and I can generate similar dashboards to identify things like, I will show you this later. To determine, for example, the attack path. And this is kind of like the key things that also I would like to that you can take from this talk. You need to determine not just where it is found, but how would an adversary would reach that vulnerability, right? Can that be reached like directly from the internet? Can that be reached only after they have initial compromise and they are inside your environment in a container, in an EC2 instance, like somewhere? Do they have access to certain data? This is also super important to determine the impact, right? I mean, if they have access to a test environment that doesn't have access to any real data or just test data, then it's not as impactful if the vulnerability is actually exploited than if it is exploited in a like production environment that has access to production information. So determining this efficient attack path or the most impactful blast radius, I think it's super, super important. And well, I can use now Neo4j MCP to do the analysis of these attack paths. And for example, in this case, the most likely attack path for the account front end is a certain server-side request forgery vulnerability that if exploited, then that will get into my service mesh. And because it's a server-side request forgery vulnerability, it would allow the attacker to then call services as if it was actually the service, the backend hosting the service hosting the front-end application. And then based on that, get access to certain information, right? And now it's not considering mitigations about using IMB, the IMC or the AWS service to like get access to credentials, so getting the STS token. We obviously have protections for that and mitigation for that. And it's also not considering that this is not an attack path that can be exploited like via a URL. If you need to exploit Axios dependency, calling an existing endpoint or URL that Axios is calling. And I will try to move faster because I am running out of time. And then for the largest attack path, hopefully, let's see if I show you in the real data. So for the most impactful attack path, it's that hey, somebody gets access to the account front end. and then are able to perform a remote code execution via deserialization in Next.js. They can get container code execution, and they manage to do a container escape, exploiting external vulnerability for container escape that might exist in the container. They could get access to the node, and once they have access to the node in the Kubernetes cluster, this goes like bad, really bad, right? We're probably even getting administration level access. So determining that attack path is very important, and again, now with AI, it's easier than in the past. Now let's talk briefly about modern exploit development. Code is growing fast, so exploits are code after all. So if you can use AI to create code, a lot of rubbish code and a lot of vulnerabilities, and then if you can use AI to find vulnerabilities, why not using AI to generate exploit? So we experimented at Lyft here internally to build our own kind of like exploit pipeline, so that when we do the analysis of like, hey, I mean, this vulnerability is of biggest concern, and this is the one that we need to focus, then we can go on and in a more constrained environment, have an assistant that helps us to perform the security testing, kind of like red teaming, and do the exploitation of such vulnerability that resembles a real environment. You probably have heard about Mythos, and you have also heard about the backslash on Mythos. That is not so great, but it's also pretty great. And other models being able to replicate the results from Mythos that can go from just, again, like prompts to full mining of the vulnerabilities and exploitation of those vulnerabilities. So it's something that we are experimenting. You can build exploits automatically, but you need a lot of context. And once again, you need to know good your environment. So in order for exploit to be able to run in your environment great or easy, then you need to provide a lot of that information that I shared previously for the analysis for the exploit to be actually created. And well, we are using AI to kind of determine vulnerabilities that are likely to be exploited. And once we have a vulnerability that is likely to be exploited, we are experimenting on how to build exploits for such vulnerabilities. And so far, we are not doing like impressive. We are just generating kind of like the scripts or the tools that then a human needs to run. But the good thing is that we have like a specific information for Lyft that helps the model to determine better kind of like the paths or the configurations or the tools that need to be used in order to attend the exploitation. And now talking about the blue team perspective, it's pretty cool that you can, well, it would be great that you can determine the real risk, right? And not just based on severity. I mean, severity, again, is something that is based on metrics that might or might not apply directly to you, but what they were applied to where the vulnerability was researched, was found. You need to determine actually if it's feasible to exploit and how impactful the exploit would be. I mean, how bad will be if somebody actually exploits the vulnerability. So you need to be able to calculate then based on known information that only you as like a person or organization that knows what your environment have. To do that, you can do a lot of contextualization, like explained before, in order to determine attack paths and also determine blast radius, but also determine kind of like the data that is connected. So in case that a vulnerability is exploited, how that data is exfiltrated, or what data can be exfiltrated, and what will be the material impact. And material impact, I mean money, right? So we are building in our internal AI tool that can run jobs. For example, in this case, it's a job that gets threat intel externally, and based on the threat intel, tells us like, hey, I mean, these are vulnerabilities that are of biggest concern in the like cybersecurity industry. In this case, a couple of Apple vulnerabilities in iOS and WebKit. And then based on that information, we can ask our conversational interfaces, hey, I mean, get me more details about this vulnerability in my environment and how many endpoints in this case can actually be affected. So it allows me to get like directly that information of like, hey, I mean, these are the devices that this specific vulnerability have been identified, that this is the actual risk of those endpoints in case that they are impacted. And then this can be like deep and do the triage of like kind of like more information or raise more information that we have on the dependencies that we use, on the vulnerabilities that exist on those dependencies, and then from all those, which one are reachable, which one are more likely to be exploited based on the actual conditions that exist. In this case, it was an analysis for a set of vulnerabilities found in the front end of our authentication system, and then it required like some prototype pollution in order to trigger the vulnerability, and because of that, it required some kind of like other supply chain exploitation. And then I ask about the impact, and then this is probably the important piece. So it's important that you can put a numeric and money value to the vulnerabilities, so that, well, does this application have a lot of data? If so, then what will be the impact? In the case of our account partner will be impacted and actually get access to user information, then that will be like huge cost for like fees on violations based on the complaints frameworks that we have, the service disruption. So yeah, basically it will be big. Can you hear me? Sorry, I hope. And well, going deeper into this analysis, I then later mentioned the mitigations that we have in place. And because of the mitigations that we have in place, we can actually reduce the super high severity on these vulnerabilities that were found. So it's possible to do automated exploits. It's also possible to do automated fixing. So if you are finding things fast and analyzing those things fast and being able to exploit some of those that are of biggest concern, you should also be able to build fixes for your systems that can reduce the likelihood. So final call, please prioritize based on exploitation, prioritize based on impact, on the actual business impact that you will have. Sorry, can you hear me? I hope. Awesome, thank you. And well, with that, I finished my talk. I don't know if we have time for questions, but well, you can find me in LinkedIn, on GitHub with my handler, and you can ask me directly anything. Yeah.
Does anyone have any questions for Hector? I can bring the mic, and that way he can hear you. Going once, going twice. Okay, going thrice. No questions today, Hector. You can also, I believe, reach him through Discord as well, through the Discord channel if someone else has a remaining question. And otherwise, thank you so much for being here with us, Hector. We really appreciate it, and you have a great rest of your day.
Thank you. Keep enjoying
Thanks
besides
so much.
Budapest.
Bye.
Bye.